Smelly cat, what are they feeding you? Smelly cat, smelling cat, it's not your fault. Well, that's Smelly Cat. If you can tell me, if you can be the first person to tell me what TV show that's from, next time in class, I'll give you a piece of candy. Anyway, here's what we're going to do today. So let's read this problem. It says you sell tickets for admission to your school play and collect a total of $104. Admission prices are $6 for adults and $4 for kids. You sold 21 total tickets. How many adult tickets and how many children tickets did you sell? So remember, it has to be a total of 21 tickets, and the price, or the total money that you had to make was $104. So there's only one number for each adult and one number for of kids tickets that would work. So this is the type of problem that we're going to work on solving this chapter, and they're called systems of linear equations because we're going to end up making, well, I mean, you could solve this one by guessing and checking numbers, but some problems like this you won't be able to, and you'll have to write linear equations for them and solve them. They're going to be two linear equations. That's why it's called a system of linear equations. So what we're going to do in this video is work on remembering how to write linear equations from situations like this. All right? So our learning target or our goal is I can write linear equations from real life situations. This would be 6.0 is what we're calling it, because we're going to do it before the rest of the sections. So just to recap a couple things. When you're writing linear equations, first determine the variable or variables. So what things do you not know? There's going to be more than one variable. All right, first got to figure those out. And then something else to help you really, it could be the cubes and then the keywords to help you write the equations. I don't have any other suggestions for you, other than you just have to get used to writing equations from the real life situation. So you're going to have to do more and more examples and just work towards improving that skill. So just to recap, cubes, and we're going to be focusing on the first four, would be circling any key numbers. Okay, circling any key numbers, that does help sometimes. Then underlining the question that you're trying to find, and boxing any math action words. Okay, those three will help you then write the equation. And then we'll talk about solving and checking. All right, math action words. To recap, these could be in your notes from like chapter 4, chapter 2, chapter 1, I don't know. Addition, we have lots of words for addition, like add, increase, added, more, sum, and plus. Multiplication would be times, per is a good one, of is a good one, multiply, product, and each. Subtraction, you might see the words less than, less, minus, decrease, subtract, and difference. Division, divided by, quotient, divide, split. And then equals could be is, totals, or is equal to. Those are all common ones for those special terms. So let's use some of these to write equations for some systems of linear equations, meaning there's going to be two equations. All right, so I'm going to break this one down for you. It says the height of a triangle is 1 centimeter less than twice the length of the base. So we have our triangle just as a picture. Triangle. Whoops. There's my triangle. Let x be the length of the base. So we're going to be, x is going to be the length. So we know that's one of our variables. We make the other variable y, but what is that going to represent? So let's look at our problem. The height of, well, we don't know the height. So the height would be 1, and the length would be another. So we'll make the height will be y. So like I said, first identify the variables. Height of triangle. All right, A, write an expression, or we're going to say an equation for the height of a triangle. So the height, y, is going to be equal to, what is the height of a triangle equal to? It says it's 1 centimeter less than twice the length of the base. So if we go back, cube says to underline or circle numbers, underline, and then box math action words. Circle numbers 1 centimeter less than twice the length. Twice. All right, underline keywords less than, of, and then is. So we've got height is, so y is 1 centimeter less than twice the length of the base. Twice of the base would be 2 times x, because the base is x. And if you're saying one less than that, you have to subtract it from it. We know that less than is subtraction, so it has to be after it. Because if you're taking something less than something, it has to be subtracted after that. So there we have one equation already. That's letter A. Now letter B says write a function, rule, or an equation for the area of the triangle. All right, how do we find the area of a triangle? Remember, area is equal to, of a triangle is equal to 1/2 base times height. So in this case, the area, we're going to have more than one variable here. Look at the 1/2, the base, which is x, times the height, which is y. Or in this case, 2x minus 1. I could go in for the y. Okay, that's actually what we are going to do in a little bit. So it says, then what is the area of the triangle if the length of the base is 16 centimeters? Interesting. Well, we're not going to do that right now. We just wanted to be able to write equations from the situations. So we will come back to that. Let's do another situation. We're just writing equations. This one says, planning an exercise program. So, Ashley uses the rowing machine. I don't know if you know what rowing is. It's like rowing a boat, but it works certain muscles. And the stair machine at the gym for an exercise program. Her trainer wants her to do an exercise program that meets two conditions. So we're going to have two different conditions, and that's actually going to mean two equations. So one, Ashley will exercise 40 minutes, dividing her time between the stair machine and the rowing machine. All right, so we're going to make two variables. It doesn't necessarily just have to be x and y. So let's say our two things that we don't know are how long she's going to be on the stair machine and how long she's going to be on the rowing machine. So well, we can do x and y if you want, because otherwise stair machine we'd be using an s, and that could get kind of weird, but we'll try it. S is going to be time on the stair machine. Maybe we should look at the second one just to make sure we're dealing with time. Ashley will spend twice as much time on the stair machine as on the rowing machine. Okay. So hold on here. Um, R is going to be time on rowing machine. We're going to use those two variables to write two equations, actually. Let's look at the first one and see if we can make an equation from number one. Ashley will exercise for 40 minutes, dividing her time between the stair machine and the rowing machine. So let's just say the stair machine time plus the rowing machine time is going to be equal to 40 minutes. Am I right? I think that's how it would work. That's pretty basic. Let's then look at number two. Ashley will spend twice as much time on the stair machine as on the rowing machine. So, twice as much time. So the time on the stair machine will be 2 times the rowing machine. Twice as much time on the stair machine as the rowing machine. So the stair machine time is going to be twice as much as the rowing machine. That's how I'm going to write my equation. Okay? Alright. Now we have two equations. That's all we wanted to do. Write equations for them. Let's try another example. This one's going to be a little tricky, but we'll go through it. Travel. A traveler flies from Charlotte, North Carolina, to Los Angeles, California. At the same time, another traveler flies backwards from Los Angeles to Charlotte. The airspeed of each plane is the same, except it's going in one direction. The airspeed is going in this direction. Probably should have used red. Sorry, the wind speed. Oh, the airspeed is the same. The wind speed is different. All right. What is the airspeed. What is the wind speed? Well, we are going to just write equations first. So what do we need to write equations for? Well, let's do trip from LA to North Carolina. And then we'll do North Carolina to LA. So their airspeed is going to be whatever the wind speed is, and then plus whatever whatever their ground speed is, the regular speed, plus whatever the wind would be. So if you're going from LA to Charlotte, you're actually going with the wind. So you'd be going 550 miles per hour according to that. Let's look at what are our variables. Well, our variables are airspeed and wind speed. So there you go. A equals airspeed. W equals wind. So if we're dealing with speed, let's go here. 550 plus, you get the extra airspeed, whatever the wind speed. That's going to make whatever your airspeed is. Okay, going backwards, if you're going from North Carolina to LA, you're going against the wind. So you have that 495. Forget what I just said. That did not make sense. I just realized. Um, your airspeed, how fast you're going in the air, is changed by the wind speed. So if you think about it, when you're going from LA to North Carolina, your airspeed could be whatever, it could be 500. You add the wind that's behind you, and that's getting to that's going to take you to whatever the ground speed is, which is 550. So your actual speed is 550. Now, from North Carolina to LA, you might think it's a little bit different. You have your airspeed, and you're actually subtracting because the wind speed is going against you, so you have to subtract whatever the wind speed is from your airspeed, to get to the 495, which would be your actual ground speed, 495 miles per hour. All right, so there's two equations for that, and we'll soon learn how to solve for both A and W. But then let's just go back to our last one. So you sell tickets for admission to your school play and collect a total of $104. Admission prices are $6 for adults and $4 for children. You sold 21 tickets. So let's say there's adult tickets. Those are our two things we don't know. The price for adult tickets. No, we know the price. Tickets sold. And K will be kids tickets, or children, whatever. Kids tickets sold. So let's look at, we'll make two equations, one for the cost and one for the number of tickets. So total number of tickets is going to be 21. And that would have to be made up by the adult and the kids, right? There's no other prices. So it's the adult tickets plus the kid prices would be equal to 21. The other one is the price. So $104. So what makes up the price? Well, $6 for an adult ticket. So 6 times however many adult tickets plus 4 for the kids tickets has to equal to $104. So there we have two different equations now set up for this situation that will ultimately help us find how many adult and kids tickets are sold. All right. So going back to our goal, that would be writing linear equations from real life situations, and these are going to be dealing with two equations each, or systems of equations. All right. Smelly cat, smelly cat.